Have you ever seen something on the internet and instead of asking yourself, hey, do I have enough money to buy this? Instead you ask yourself, hey, do I have even more money to try and do it myself? Well, the answer is yes. So what I did here was I took a Bluetooth module, a IR transmitter and receiver, and a LED strip RGB, as well as a photoresistor, and I've recreated a Bluetooth activated LED with a sensor on processing showing the difference between what the remote says it is and what the sensor says it is for colors. Now, the applications of this are actually pretty interesting with the photoresistor and light, and also very educational from the Bluetooth standpoint as well as the IR. To begin, we're going to be discussing the Arduino code that is passing through into processing and showing us the screen that you saw in the introduction. So I'm going to start my screen recording now, and what you're going to see in the screen recording is the toggle is off. Obviously the lights are off. If I press the toggle on, it's going to turn on red. So if I switch to green, the toggle changes from red to green. If I go to party mode, lights will change frequently. But if I turn it back off, what's going to happen is the party indication is still going to be on. And that's important because when I turn the lights back on, as you see, it goes back to its previous setting, and that was really important in the code. Finally, let's discuss what actually goes on in the processing code as well as the processing monitor, as you can see right here. So let me do another screen recording so you can see what's going on. And what's interesting about this is when I turn it on, it'll show me the last color that's on, as well as to the right you see the sensor on the actual recording. Here it's to the left, but you can see that the sensor is showing a light hue of red, and that's quite interesting because I haven't set it up in a way. The only thing I've done is change the color mode from RGB to a hue, brightness, and grayscale setting. And what that does, it's very interesting because I've just mapped all of the different resistance values, and it lines up pretty well to what the colors actually are. And obviously there are changes in what's going to be happening with the actual resistance, but as you can see, they're all pretty close. That's going to be blue. You can kind of tell that's going to be green, and you can really tell it's going to be red. The interesting thing here is if you switch it to white, it actually stays red, and that's because white has the same intensity as red here. And then this is party mode. Obviously, as you can see, the colors are changing. The remote control, I've actually just hard-coded in a continuing thread of color spectrums so that it just goes through without having to worry about what's actually going on in the remote. So that's where the discrepancy is here. To conclude my project, I kind of want to briefly touch on the applications of something like this sensor. What's interesting about this is not only is it a Bluetooth controlled LED, which was just educational for my purposes, but it also showed me an application of the photoresistor, which could be used for colorblind people when they're crossing the street, when they need to see a red light or a green light or a yellow light. And this shows that you can actually, with enough fine-tuning on photoresistors, emulate the cones in your irises to be able to see, essentially, different colors. And yes, there are some discrepancies where if you have white, it's still showing red, but obviously that's just, you need more variance in your resistivity, and then you can get a higher spectrum of colors. So that was my ENME351 final project. I hope you enjoyed it, and thank you.